Class. This is my project. I'm working on a windmill electrolysis AHP systems and just doing some flow charts and stuff. And the idea here was to start getting these flow charts kind of cleaned up and separated and just kind of consolidate different parts of my graduate project and isolate different parts and figure out which pieces that I don't really need to worry about, what parts are more important, what should I focus on, because my grad project just got too big, and right now I really saw how these tables were kind of helping me break it down. So if you look at the top of this flow chart, we have this windmill electrolyzer, and then I have 6 categories that come off of it first. It's environment, human health, windmill AI, weather AI, PEM fuel cells AI, and the power grid AI. So I wanted to break down the environment first of this flowchart. And as you can see that some of the things we look at with windmill electrolyzers is the bats and the birds. We could also have tornadoes, ice storms, fires. We could have earthquakes, lightning, magnetic disturbances. And then, of course, when you install this windmill, it's going to throw the ecosystem out of balance. So you have to rebalance it and or figure out what you want to do to make sure that this ecosystem is going to thrive and you're not killing any endangered species. And then this weather pattern optimization here at the end there is just going to stem from the ecosystem balance. And this could be maybe we're not balancing the ecosystem so much, but we are optimizing it for energy usage, so we're not so concerned. So there's 2 sides to that coin. But that's the environmental side of this, and I'm just kind of looking at the different parts to start getting a better understanding on how cybersecurity could play a role into this windmill electrolysis AI system. So I'm identifying weak parts. So depending on site, there's going to be different weaknesses in my windmill electrolysis system. And here is the pairwise comparison for the environment that I used. You can see the key there, and it just further breaks everything down into the decision matrix. So that's something you can look more into, but this is where those numbers came from in that flow chart. Now the next piece of that flow chart is human health, and this is the same one, but this time we're stemming off of human health. And I came to find out that windmills cause a lot of problems with humans, even though they're not directly connected. So just having them can cause people to have headaches, sleep problems, tendinitis, anxiety, concentration issues, night terrors, nausea, irritability, and dizziness. And I'm sure there's more on the list, but I was surprised to find all of these different symptoms just living by these windmills. And, one of the things I want to do with this Cyber Shield is set people, hearts at rest and kind of help them relax. So this human health spectrum of it kind of really opened up my eyes to look a little bit farther outside of the box of what I usually do. But there are, you will be able to draw direct arrows and lines from this human health issues to the windmill AI systems and how cybersecurity is going to be advancing. So, but this is the human health section. All right. Now we have a priorities in the decision matrix again. And as you can see, I prioritize concentration the most. And then sleep problems, headaches. What I like the least is tendinitis. I hate night terrors. That's my lowest percent. I hate nightmares. And then there's your decision matrix. So the next section of this flow chart we're going into a little deeper now is going to be the windmill AI and the weather AI, and they kind of work together. The windmill AI has is going to have a rotor speed control loop, a stator reactive power control loop, a deviation signal control error, and this is all going to be interconnected into a multi-control loop that will be synchronization time. And then, of course, with the weathering system, we're going to have inputs from IT communications lines, and we're also going to have our own weathering system built into our database so it can go on autopilot mode when you want to run off the memory of the land, the weather patterns. And this system here is going to be a little bit more robust because it's if the IT communications line isn't working, then the autopilot would automatically kick on. And there's these two systems basically they work together to help get the correction time and keep track of the different information that's needed to make a good weather AI system, and just kind of pairing that up with the windmill for best results is kind of what this flowchart is supposed to open us up to. And it's also supposed to give us some insight on all these big parts that are relied on to keep this system up and running. So this could be, parts of the system that could be cybersecurity hacked and could cause a lot of issues. Then the next part is the power grid AI section of the windmill electrolysis. And this is kind of like the electrical part. So we have the windmill that connects mechanical power to the electrical power, and then we're going to get to the power grid. So with the power grid here, we have different things going on. We have the electrical failure, the mechanical failure. We have a centralized data processing unit. Energy optimization, ultimate observer technique. This is going to help us get all our costs down to be minimized. And then we're going to be going through and building this system into some kind of smart grid. But eventually it's going to turn into a future grid, which would be much more advanced than the original smart grid. These are the different sections I'm looking at to see how cybersecurity will play a role into it. I know some overflows can happen. We can change the signals. You could add in a whole new signal. Different disturbances could happen from heat and all sorts of things. So we're looking at those a little bit closer and just trying to figure out which ones are going to be the most important for this project, for the grad project. All right, here's the last one. This is the artificial intelligence for the PEM fuel cell, proton exchange membrane. And the sections that run with this AI is going to be temperature, pressure, humidity, flow rates, cooling water, current, and voltage data. And you can even add like a Nyquist or more stuff with the potentiostat. So this is just some of the basics. But I wanted to get these out there and maybe start trying to normalize what the what are the chances that I'll catch a cybersecurity hack with these kind of sensors and setup systems, and which one should I be looking at to be doing more than one job for me? Because these sensors are going to be set up to be using a cybersecurity shield as well as using AI. So there you have that part. And then these are just my references. I have a lot more that I want to add to the paper still. I'm really interested in the cybersecurity part of it. Trying to get that cybersecurity shield put into place and figuring out what mechanical parts maybe haven't been worked on yet. What kind of innovations are there with these cybersecurity shields, and how are we going to connect software with hardware and mechanical engineering? How do we interconnect all these in a smooth, gentle way where we're getting rid of vibrations and we're taking in good data, and we're able to put good filters on that information and ensure that it's the information we're supposed to be getting. And then just keeping your databases from not overflowing and stuff. So definitely a lot to think about. This flowchart helped me open my mind up a little more to it. When I go to write the paper, it's going to be a lot longer. So hopefully that'll give me the opportunity that I've been needing to kind of build past some of the writer's block that I've had this term. And yeah, so thank you very much for watching my video.